Welcome to the second day of IEEE-HKN Pathways to Industry. My name is Jim Conrad, and I am the current IEEE-HKN president. I would like to thank you for joining us. Sorry for the delay. We had some slides issues that we're trying to resolve with our panelists, but let's get to it. First of all, we're going to have some, if we can go to the next slide. We're going to have some panelists, and their affiliation of their IEEE society is shown below. We have Iman Hamad, John Proeller, Nicholas Williams, Anthony Vitro, and Karen Panetta. Each one of these are recognized experts in their fields of communications, computing, sensors, signal processing, and cybernetics. And what I would like to do now is to give you a little flavor of what we are going to have our experts talk about. Next slide. So we asked our panelists to prepare for these questions and also other possible questions that you may have for the what is the next big thing in the next 5 years? What are the exciting new technologies? What are the career opportunities? How do you prepare for these career opportunities? And then these companies that will be hiring for these opportunities, what skills does a graduate need for those, or for somebody who is in their first few years of industry? Next slide, please. So here's the format, is that we're going to have each one of our panelists give a brief introduction to their area and present 1 or 2 slides focusing on their technologies. They're going to focus on what the next big thing is about 5 years out. And then after all these presentations, we're going to ask you to ask questions. Now, what we would like you to do, though, is put your questions in the comments box, because if you go to the Q&A, we actually can't see them backstage. So if you have questions, please put them in the comments area. Without further ado, I would like to introduce our first panelist, and we'll go in order from how they appear in the original slides, and that is Iman Hamad, who is the Director, Innovations in Science, or Innovations in Systems, Trust and Resilience, ISTAR. Thank you, Iman.
Hello, can you hear me?
Yes.
Thank you for having me. Let me just share the one slide I have. Can you see my screen? Can you see my screen? Hello, everybody. My name is Iman Hamad. I'm currently an assistant professor with the Texas A&M system, working primarily. My research is focusing on interesting problems at the intersection of communication, networks, intelligence and distributed systems, and dynamics, or what we can call cyber-physical systems, or cybernetics. What is this? It's how to ensure that these systems continue to operate when the atmosphere around them or the environment has high levels of uncertainty, especially when we talk about cybersecurity and cyber attacks or adversarial environments. So it's a very interesting research area for me. Why? Because of the complexity and because it's kind of a moving target game. We have the attackers or the adversaries who have access to the same resources that we have access to. So it's always interesting to see what the next will present for us. So as I tried here to summarize in a small slide what could be some of the things that need research, focus on, and all of the above. I come from an industrial background, so after my PhD, I worked in industry for a couple of years. And the interesting thing for the next 5 to 10 years is we will continue to work on security. We'll continue to talk about how to make our systems, our software, our humans that operate in those systems more resilient towards those uncertainties, to what if and when can happen. So I'm sure everybody heard about the pipeline attack, colonial pipeline attack, Stuxnet, for example. If not, please look them up. Within that, what we want to do is develop, as engineers, develop our operational systems and the control of those systems so that to leverage the different degrees of freedom that we have from an optimization, from a flexibility, from a distributed resources, so that we can adapt our operations in anticipation of what could happen and also in response to what happens at the moment. So what that means is a risk-aware operation. And we as humans, we are kind of doing that out of, as a result of a long-term evolution. So that's, you always think about, should I do this? Should I do that? Like if this happens, how I should react. So that's the risk-aware operation. The other thing that we need to develop as engineers is focus on how we build new innovation. And emerging technologies, we are noticing that because they are developed to be ready for the market, like functional and ready for the market, they do not necessarily have the best built-in security and privacy controls. So what we really want to do as engineers and our responsibilities is develop that set of skill to be able to develop systems that are trusted and they have resilience by design. The other thing is analytics is everywhere, machine learning is everywhere, and it's now embedded as part of that closed loop operation of any system. So we need to be able to work and address as professionals and as researchers the problems that arise from embedding those in a trusted way, and also be able to monitor and audit and make sure that they continue to operate in a trusted way. So this is in a nutshell, cyber physical security, resilience, and I'm looking forward to the discussion that comes afterwards.
Is going to be George Proler, and he is going to be representing the Computer Society. Thank you, George.
Thank you. To start out, the exciting technologies are going to be things like quantum computing, AI, the Internet of Things, virtual and augmented reality, communications, and they all have a ton of career opportunities. Everything from intelligent transport systems to medical, finance, education, cybercrime. Those are some of the opportunities. What computer security looks at is the fact that attacks are going to continue. Anything from denial of service, malware, data theft. And if you look at the numbers, we're talking about cybercrime reaching about $10.7 trillion per year in 2025. So that means there's a big incentive for computer security jobs. My predecessor talked about the fact that we need to engineer in security. So some of those other jobs are, we need to prepare and build strong systems, keep them up and running, defend those systems. And then when there are things that happen, then we need to look at investigation so that we can learn from that and then continue to build strong systems. So on the other side, then identify security measures to incident response. That seems to be something that we forget about. We hear that there are attacks, but we don't hear about what the response was to that, and it's very tough to get the lesson learned. We look at assessments and audits. How well are we doing? If we don't know how well we're doing on anything, we continue on a path, and that path could be negative. Researching new attack vectors. And with the dawn of AI, we're going to have to look at automating security improvements because the other side is automating security attacks. Next slide, please. Okay, this is the acquisition process. I took this out of defense acquisition, and it starts with taking a look at what is the concept, what it is that we want, how are we going to engineer it, what happens once we begin to deploy it, and it really extends out to decommissioning. Next, please. And this overlays security on there. And the fact that security starts at the concept. So can you be a security engineer and can you be an acquisition professional? And that answer is yes. And so the point I'm trying to make is that the concept of security isn't limited to computer science. It's actually something that has to be engineered in. It has to be followed. It has to be a process. It's a part of project management. And as I said, security goes all the way to decommissioning. And any questions in the back, I'm here for the hour. Thank you.
Thank you very much, George. And our next speaker is going to quickly introduce their area. That is Nicholas Williams, and he's the Director of Product for X-Core Therapeutics.
Thanks for the introduction. I'm the invisible man in the PowerPoint, and today I'm going to be talking to you about medical devices largely. And I'm going to use diabetes treatment as sort of a guise to get an understanding of where we're going. Just about 100 years ago, the insulin was first discovered, and that was the first time that we were really able to treat diabetes and decrease deaths by about 97%. But we didn't really know when to dose this treatment, and it wasn't until about 40 years later, with the invention of the first glucometer or glucose sensor. Such an important discovery that it was commercialized about 3 years later. And what that allowed us to do is get an understanding of dosage and of timing. Now, this device itself was large, it was cumbersome, it was incredibly expensive, and it was fairly inaccurate. So we didn't see any significant improvement in patient care until about the 80s with the invention of the self-monitoring of blood glucose. Now, that's what we generally think of when we think of glucometers. That's the handheld device with the finger prick of blood that's patient-guided. That advancement decreased hospitalizations by about 50% per year, just transitioning it from a large cumbersome device, now putting it in the hands of the patients. Now, unfortunately, it's still a relatively painful experience. The patients still have to remember to monitor their blood glucose. And so in 2017, we saw another advancement in the continuous monitoring of blood glucose. Now, what that does is it's an implantable device that can monitor this disease state every second and wirelessly communicate to an implantable treatment system. And that reduced hospitalizations by another 50% per year. Significant improvements, but again, still relatively expensive, still painful, not as smart as we would want it to be. And so you see in 2021, there was over $500 million invested into improvements in monitoring and improvements in care for diabetes. And I'm focusing on this because what we're going to see is all disease states exist somewhere on the spectrum, from the invention of treatment to the modernization of care. And in the next decade, in the next really 100 years, we're going to see advancements in not just diabetes care, but really all care, guided by sort of 4 pillars. We already talked about precision outpatient sensing. Actually, this is a photo of a COVID-19 detector, which saw a significant surge in the last 2 years. X-Core Therapeutics, and there's a lot of other companies are working on less invasive, smart treatments. So we are working on an improved method to remove carbon dioxide from the blood of COPD patients, to improve survivability, to improve the life of these millions of patients a year. And combining precision outpatient sensing and less invasive and smart or more intelligent treatments, they're going to generate a significant amount of data. So much so that we need a strong focus on data infrastructure, security, patient privacy, and all of these are going to need the advancements in AI and need focus on AI-guided care. Again, we're seeing hundreds upon hundreds of millions of dollars being spent on improving this. And so irregardless of your focus, irregardless of your background, there is a place for everyone in medical devices in the next 10 years. And I'd be happy to speak to anyone about sort of any of the various different opportunities. Thank you.
Thank you very much, Nicholas. And our next presenter will be Anthony Vetro Vice President and Director, Mitsubishi Electric Research Labs.
Hello, everyone. So Anthony Betro here, share with you a few exciting things that I think are happening within signal processing society and also personally interesting to me as well. So first thing in the multimedia signal processing area, I think many of us are familiar with today's smart speakers and virtual assistants. They have a lot of advanced speech recognition and processing in them. I think there's still huge amounts of investment going into these devices to make them kind of more aware of their surroundings and interact with us, understand our emotions, our patterns. So I think it's definitely an exciting area to be looking at and working in. Nicholas just talked to us about a lot of medical devices. I think that there is a lot of interesting scope for health monitoring. In particular, I'm really excited about kind of non-contact remote ways of doing health monitoring, like, for example, estimating heart rate just from camera data. So no need for any contact devices. And then I think there's also a lot of interesting things going on in just surveillance and monitoring systems, of course, AI-based. We're able to kind of understand movements, behaviors, patterns, detect suspicious activity, and so on. So again, very interesting space. Another exciting area is in computational imaging and array signal processing. So just a few years back, using computational imaging technology, we were able to recover a first image of a black hole. And in fact, people from Signal Processing Society were actually involved in this very big worldwide project. I'm sure everyone is seeing a lot of interesting advances in cell phone cameras. So you see these multiple lenses on the back. This is all making use of computational imaging to not only take better pictures, but kind of post-process images and videos after the fact. Medical imaging, big area, reducing acquisition costs and getting better images. And I think there's a lot of interesting things going on in the infrastructure monitoring and resource exploration space, where again, you use signal processing techniques to kind of image underground and through different layers of the earth. And lastly, automation and autonomous systems is a really exciting and interesting area. Of course, self-driving cars, drones come into play. And I think robotics is also going through a huge paradigm shift right now. You're seeing robots becoming more and more capable, able to interact with humans in the world. And this is a particularly interesting area, I think, because it really blends, you know, different disciplines, perception, the control, machine learning, and so on. So look forward to talking with you in the Q&A. Thanks.
Thank you, Anthony. And our last speaker is going to be Karen Panetta of Tufts University, and she is going to be representing Systems Man and Cybernetics Society. Karen.
Thank you, President Conrad. First, I want to let you know that I am a member of the Signal Processing Society, the Computer Society, Robotics and Automation Society, and today I am representing the System Man Cybernetics Society. That just shows you how interdisciplinary all these things are. Our previous speakers have spoken a lot about the specific types of technologies. I really say everything in AI is the future. And specifically, I'm going to make some generalizations. Right now, there's a plethora of data out there, but getting it annotated, getting it those ground truths that's necessary is a huge problem. So anything that can help us better curate data would be a wonderful field. But even if you are not into computer science, you don't need to be developing the foundational algorithms of artificial intelligence, machine learning. But we're going to need folks that can build toolboxes so that other fields, whether it be medicine or business or entrepreneurs or marketing, can utilize these toolboxes to be able to explore and explain things better and do their jobs better. Now, one thing that I'm going to push that I think is really important is getting different perspectives. One of the things about HKN students is we're all really well-rounded. I think being able to understand entrepreneurship and other professional development skills are really key to building that type of persona that's going to allow you to go from one field to the other. And finally, you know, I want to talk a little bit more about the types of technology specifically. It is true that biomedical, security, the medical fields, business fields, even education, AI can be a great tool with augmented reality and eye tracking to help different abled people understand afflictions like autism or even Alzheimer's, to understand how we can treat these types of things and maybe come up with interventions to help people with healthy aging. So this is a wide open area, and the skills, the technical skills you build in your own field are really important, but I want you to think about how you can integrate other skills beyond your field. So with that, I would like to just, you know, say I'm going to be here and to talk about any specific technology while we go along. So thank you.
Great. And so now that we have heard from all 5 of our panelists, if we can bring them all back, and we will ask we'll ask questions from the audience, but don't see any right now. So the first thing I'm going to do is ask one of the ones that we asked our panelists to prepare for, and that is, if you are in a university program, you're in your junior and senior year, and you want to get a good background and a skill that is going to be useful for these technical opportunities 5 years out, what would be a good class to take in your junior and senior year, or good classes to take during those times?
So I'll just throw it out there that you got to, you know, everybody needs to program in some, even if it's Python. Somebody's got to learn how to. It doesn't matter whether a lot of folks say, I hate I only want to do hardware. You've got to learn some sort of programming and simulation tools.
Yeah, I want to add to Karen's point that she mentioned earlier about interdisciplinary. I think the lines between specializations are blurring. And that does not mean that you need to be a specialist. You need to be a specialist, but you need to be open to deliver your skills across the horizon. So 2 skills, from my perspective, data analytics, you need to be able to do the basic, understand what data analytics is, and be able to understand algorithms and the weaknesses and strengths. And if you're not willing to be part of the implementation and testing, that's fine, but understand the ecosystem, the capabilities, and the limitations. The other point is security and privacy. At least understand the risks and how those risks map to your systems that you're developing or working with.
Yeah, I want to echo that point in that if you, as you heard from sort of everyone's talk, there are tons, many different focal points for every single specialty, and given that there are requirements for just about everyone in everything. So what I would say is understand the basics, because the fact is we don't truly know what the actual necessities are going to be in 5, 10 years, but the basics are going to be the foundational building blocks for what we need to know, and then get an understanding of interests. So I would say some of the more core classes at first, and then get an understanding of, you know, what are the current implementations of those, what are your interests, and then build those specific skills from there.
I'd like to throw in, learn to communicate, learn to write well, learn to write technically, learn to speak well, learn to organize your thoughts, because everybody's going to end up with needing to give an elevator talk. You're going to have 2 minutes, such as we have 4 minutes to get a series of ideas across. And so I believe the communication is important.
All right, great. Thank you very much. Our next question comes from Joe Green, and he asks, now more than ever, there's a focus on incorporating lifelong learning practices in your career to stay relevant. How do you recommend we stay up to date on where industry is going, and what practices or what best practices do you use to expand your technical skill set?
Sure. I can start with that one. So there's many things to do. One of the things that I love is, and I love being part of these societies, is I get to review papers and articles that other people submit on the latest and greatest technology. And there's no better way to find out what the hottest topic is than to be reviewing and getting the details of something on the ground floor. So that's one way. The second way is you're already involved in IEEE. Now, when I came into artificial intelligence, I've been doing computing for over 25 years. Artificial intelligence is not, cloud computing didn't exist, Google didn't exist. So all the things that I've learned, I've had to learn along the way, and I've utilized a lot of the societies to do that. So, you know, I just sometimes just Google, not Google, I go to IEEE Explore. That's like my favorite resource. And I search for a topic and everything comes up, and then I can find the people that I want to talk to that are actually doing this great stuff and find a way to connect with them.
Yeah, so excellent point, Karen. I think we live in an interesting age, the information age, because there hasn't been a time in history where access to knowledge, information, expertise, it was easier. Like, especially with the pandemic, I think one of the good things in the pandemic, everybody all of a sudden had access to so many free and accessible resources about what is happening, where knowledge is being born. And I think with the machine learning and artificial intelligence in particular, and security, what we have witnessed during the past few years is the open source community was willing or more than happy to share everything to get everybody involved in the process of generation and development. So I think the best advice I can give you is leverage those resources. Really look at your time, appreciate your time, and spend your time wisely between these resources. Everything is available for you. I represent the Communication Society, and as Karen said, just being involved with a professional society gets you connected and networked with the best of the best, how they are thinking, how they are development, what is the real opportunity, what are the problems that we should be talking about. So time management, invest, really focus on what you want to do. Don't be scared of trying things out to really know where your passion is, and everything is available. We really are in the best times, I think.
I would also focus on, if you hear or see something that you don't truly understand, go after and follow it and dig into it. So in my role, you know, coming out of a PhD and a postdoc in electrical engineering and material science, I was really focused on the actual chemical side and the electrical side of everything. And now, in a startup and a small business, we really need to focus on regulatory. We need to focus on reimbursements and all of this. And so my learning is guided by need. And because I don't understand this, then I go and investigate as far as I can, and then I go and speak with people. And networks are incredibly important. Frankly, I think LinkedIn or these communities are a tremendous resource that can be utilized to support that level of learning.
Yeah, all the IEEE societies, they really offer a lot of resources for, you know, through the publications, but I would definitely emphasize the previous points about networking. I mean, if you have a chance to go to a conference, networking with people, that's really the best source of information to know, like, really what the latest is going on.
All right, great. Thank you all. Our next question comes from Jenna Flanagan. And this may be more focused for a couple of the panelists. So in the realm of cybersecurity, are people trying to teach the how to break it mentality? She describes experience in IT operations and finds that industry generally wants to make things, and then they have to end up going, oops, we have to take away this function or fix this function because somebody can use it to take over the system. Can one of our security people on comment on that?
So thank you for asking that question. I think it's on everybody's mind. 2 points to address here. First, we do have, as engineers, think as an engineer, it's always easy to break something. It's much easier to break something than to build it. That's number one. So this is why cybersecurity is a challenge. Number two is what we are teaching, and when we build cybersecurity programs, is you really have to understand the hacker mentality. If you are working in functions such as a security analyst or a security engineer or an ethical hacker, you have to understand that mentality. So what is the best, how do you gain that experience, is by trying to do the ethical hacking. What we say is an ethical hacking. Now, the last point that you mentioned in your question, should we remove that function because it's a risk? So the answer is not always. The answer is, let's build that function in a way that it cannot be exploited by a hacker. Let's build a function that's reliable, and we can monitor it, and we can always confidently say it's functioning normally. That's how we build our functions. Now, if there's a function that we do not trust, yes, let's find something that we can trust better than that function.
Can I jump in?
Sure, please do.
Okay. I'd like to look at it a little bit differently from the engineering. I'd like to look at it from the project manager. Project manager's number one goal is get it out the door. And all of a sudden, something comes in and you say, well, you know, we got to test this. And we go from component testing and piece part testing, and we go to regression testing, and then we say, well, we got to get this out the door because we're already building it. And security and training kind of get left off the boat. Second thing is, you have an engineering problem or something doesn't work. An example might be the lock to the front door of your house. Is that a maintenance problem, or is that a security problem, or is it a safety problem? It can be a maintenance problem to fix it. It can be a security problem to keep the bad guy from getting in. It can be a safety problem in that it locks and you can't get out and you have some type of a fire or something else. So you have to look at the fact that a lot of it becomes interdisciplinary. Then we have something we call zero-day attacks. Zero-day is that somebody finds an attack surface or attack opportunity, and nobody else knows that there's a problem. And all of a sudden it gets exploited. And all of a sudden somebody has an advantage. It's usually the advantage of the opponent or the bad guy. And then we come upon the concept of the unknowns, or worse, the unknown unknowns. We have something in there, and programming is really nifty in that. You can have some program that works great until somebody modifies it, and they make a call to another area, and that creates a buffer overflow. And the question I've always had is, it's 2020, I started in COBOL in 1970, and we still have buffer overflows. Why? Because coding is that difficult. That's all I have on the topic.
All right, sounds great. So I was looking to see, I'm going to save one question, Katie Brinker's question, for the end, because it's a great question for wrap up, but I'll do, okay, I like that. Okay, we are ready for your burning questions, says Jim Conrad. Oh, hey, I got a couple in there then. Oh, all right. So one of the ones that we actually asked them earlier is, what companies need these skills that all of you have talked about, and you know, how would you apply for example, one of these jobs that you would be offering at your companies for those of you that work in companies.
Okay. So, you know, when we talk about technology, everybody always thinks about the big companies that we know that are doing technology. But there is transportation centers that are looking for engineers to do exactly some of the things we've talked about. There's, you know, a lot of e-commerce still out there. There's so much different areas beyond the regular tech companies. And I think that that's something that I would encourage people, stop looking at the brand names and look at more of a match of the types of companies you want. And I talked about entrepreneurship in my first thing. I think that you also need to look at some startups, because if you want to get on the ground floor of something exciting, there's an opportunity. So, you know, to be on something and form something, if you really want to break out into something new, and you know, and of course everybody wants to retire when they're young. But I think that that's a great way. I would not rule those out and start looking at those. And your own schools have a tech transfer office that you can engage with.
Yeah, so I think that it's some terrifying statistic of 80% of jobs are found via connections. You know, LinkedIn is a great resource, but if you know someone, talk to someone, build your network, go to these IEEE events, go to as many conferences as possible, speak to as many people as possible. Maybe 1 out of every 20, 1 out of every 100 will lead to some next step, but that is, I believe, one of the greatest uses of your time, especially at this stage. And to echo what Karen said, startups are always looking for people. And I would say, you know, as someone that is definitely was working at a startup and has always worked at startups, they're doing some of the most exciting work, some of the most interesting work, some of the most diverse work out there. So focus on networking and expand the search.
Can I throw in one more that we didn't touch on, and maybe it's not a part of this, but look at the concept of integrity and make sure that you don't lose or besmirch your own, because it'll follow you. And it starts from academia, and it goes all through your professional career.
Good advice. All right. Let's switch to another question from Oliver. And Oliver asks, and we sensors is a part of this. Sensors are playing key roles in gathering data, which is processed by lots of other technologies, including AI. What would you say is the next big thing in sensing technologies that would help support other technologies effectively?
I would probably argue what's not the next big thing in sensors. I think sensors are, if not now, in the next 5 years, will be in everything. They will be the support structure for everything, from your refrigerator to your wearable device to your light bulb. They're going to be ubiquitous. And so that's kind of the mentality and the idea behind IoT, or Internet of Everything, is sort of what we're starting to expand it to. Sensors are the cornerstone, I would say, of really our modern society. And so as I tried to highlight in my brief presentation, there's something for everyone in sensors. We need materials development. We need mechanical engineering development. We need programming. We need chemistry. There is something for everyone, and there are sensors for every application under the sun.
Is that just too good of an answer that nobody wants to add to it?
I was going to add augmented reality and being able to do better human-robot interaction. So with sensors, being able to keep people safe, because now you see a lot of robots in factory floors or even deliveries, things like that they're trying to automate, or self-driving cars, being able to work around humans. So using augmented reality, eye tracking, and the sensors on the devices themselves, the smart sensors that tell us their status. I'm overheating, I'm redistributing load, or somebody's trying to access me illegally. I think that those other complementary types of things are metaverse, right? The new, I don't want to use the word Second Life, but more of a metaverse of operation in virtual realities as the next big social platform.
I want to add, I think one of the next big things is the sense of responsibility from a governance perspective. So let's imagine a smart city scenario and all of the sensors on the different critical infrastructure and services, including health, including public safety, all of that stuff. So we will see more of the emergence of data governance strongly, and that will highlight roles that have not been seen before. Roles as quality of data, who owns the data, what type of data is shared between different entities, what data do you need for your function, and that will translate into jobs and certain types of skills that will be related to such things. And with that, it will be overlaid with new new models for machine learning and artificial intelligence, where we will see federated learning and all of that stuff. So it's good to learn about distributed systems, how distributed system will support autonomous, trustworthy applications, and the data layers that overlay them.
All right. We are just about up with time, so I'm going to address one last question that came in from Katie Brinker. And this is actually a very nice question to cap off our entire panel because it gives all of you an opportunity to tell us about IEEE. And if you could quickly tell us, how was your involvement in your different IEEE societies and councils and other IEEE operating units? How has it helped you stay up to date with what's happening in tech?
Well, to start, education. I think also that Mom talked about, connections, about staying up to date and learning from the papers that are presented. I think that was Karen that talked about having an opportunity to review papers. Networking is super important. Being able to learn from others as well as to have an opportunity to share with others. So I think in my time, I've been involved probably about the last 25 years. I think that going to conferences, I think also having an opportunity to give back in the fact that the things that we do, we're pathfinders for others.
And I was just going to add to that, being able, if I want to get into something that I'm not comfortable with, like a new project, humanitarian project, we have the IEEE Special Interest Group in Humanitarian Technologies, or the IEEE USA Move that does all the outreach trucks and for disaster relief. Rather than having to jump right in, you've got a framework and infrastructure to bring you in and train you and learn this new technology or participate in projects you are interested in, but you don't need to start from ground zero.
So from my perspective, it helped me in two ways, similar to what Karen and everybody mentioned, is to learn and be like up to date. And the other thing is to actually contribute. So I'm involved with standards related to 5G and 6G security, smart cities. So that is our duty as engineers. So you are part of an ecosystem. You learn from one part of it and you give to the other part. You build the expertise and build to the other part. And I think it's a fabulous ecosystem because just being involved in the development requires you, will motivate you to learn more and be connected more, attend more sessions, engage your critical thinking, and this will help your career overall.
Yeah, in general, I think the IEEE societies offer a lot in terms of, just professional growth throughout your career at all the different stages of your career. I spoke about all the resources, publications, conferences, networking. You can get involved in leadership activities. These are other ways to kind of give back. And it provides a fantastic platform to publish your work and really meet all colleagues working in the field.
In addition, I feel like the conferences themselves provide, one of the best opportunities for debate that you see within fields themselves.
All right, great. Thank you all for spending your time today. I would like to wrap up by thanking everybody. Really enjoyed meeting with all of you on the panel, and I hope this was beneficial for you here in the audience. One area that we didn't talk about, how getting involved is valuable for your career as well. That includes volunteering for Eta Kappa Nu. So if you are interested in continuing in Eta Kappa Nu, being a panelist, helping out local chapters and all, I do invite you to contact our Eta Kappa Nu staff, and they'll be able to point you in the right direction. Other than that, enjoy the rest of the day. Thank you very much.